So in this video, we're going to talk about a different way to define a parabola. We can define a parabola as the set of points that are equidistant from a fixed point called the focus and a fixed line called the directrix. Now, another way to say that is, for any line and point, you can use those to define a parabola. Any point on the parabola is going to be the same distance from the focus and the directrix. And this will work for any point. So even if I have a point somewhere here, the distance from the point on the parabola and from that point to the line will be the same distance. So we can use a line and a point to make a parabola. We can also go the other way. If you're given a parabola, we can find its focus and directrix. So for parabolas that open up or down with a vertex hk, we can use this equation. Now if you notice, this is almost identical to vertex form. We just changed this a. Turns out that p is going to be the distance from your vertex to your focus. So that distance is p. Now again, our vertex is hk. So we can use our hk for our vertex and the distance p to find our focus. So we can see our vertex and our focus are going to have the same x, or in this case, h. Now to go from our vertex to our focus, we go up the distance p. So from k, we go up p, or k plus p will get us to our focus. The distance from the vertex to the focus is going to be the same from our vertex to our directrix, so that is also p. Two things you need to remember. For the equation of a horizontal line, it's going to be y equals, and it always be y equals the y value, where that line is. To find that for any directrix, we can again use the vertex. So the vertex, our y, is at k, and to get to our directrix, we move down, so we have to take away p. For a parabola that opens left or right, very similar. One thing you have to keep in mind here is the h and k switch. Our vertex is still hk, so h and k switch here, not here. So then to find our focus, right, distance is still going to be p. In this case, since we're moving right, the x value, or the h, should change. So starting at h, we need to add the length p to get to the focus. And then we don't move up or down, so our k is still the same. And then similarly, the distance p in the other direction will get us to our line, our directrix. And then we need to remember that for the equation of a vertical line is going to be x equals a value. And we can, again, find that value from our vertex. So our vertex, our x, or our h. And then to get to our directrix, we have to go backwards or take away the value p. So we're going to use this relationship, the relationship between our vertex, our focus, and our directrix. So in this first example, we want to identify the focus, directrix, and axis of symmetry for negative 4x equals y squared, and then graph. The first thing we should probably do is identify if this opens up, down, left, or right. And you can tell by what variable is squared. If the x is being squared, up or down. If the y is squared, left or right. So this is going to be left or right. So we want it to be in this form. So let's solve for x. Divide both sides by negative 4. We get x equals y squared over negative 4. I can change the notation. This is the same as x is equal to 1 over negative 4 times y squared. I'm going to write down the equation above so we can find our h, k, and p. So for our p, I'm going to say what value of p would make negative 4. In this case, negative 1 times 4 would give us negative 4. So our p must be negative 1. We can also identify our h and k. So there's nothing added or subtracted on the inside. There's nothing added or subtracted on the outside. So our h and k, our vertex, must be 0, 0. So now that we know our vertex and we know the distance p, we can use that to find our focus, our directrix, then graph. So we want to remember our focus for left to right. It's going to be h plus p k. So our h is 0, our k is 0. So it's going to be 0 plus negative 1, 0. So our focus is negative 1, 0. And then we're going to find our directrix same way. So our directrix for left to right can be our x value is equal to h minus p, or our x is equal to h is 0 minus p, which is minus 1. 0 minus a minus 1, or 0 plus 1, is 1. So let's put in what we know. So our vertex is going to be 0, 0. Focus, minus 1, 0. And directrix is at x equals 1. Now the line of symmetry, remember, always goes through our vertex. And since we know this opens left or right, our line of symmetry must be here. Now we can use what we know about the focus and directrix to find another point. Remember, the distance from any point on the parabola must be the same to the focus and to the directrix. So we can see here it is 1, 1. So if it goes straight up 2, straight down 2, that's the same distance. So that point must also be on our parabola. All right, so for our next examples, we're going to go the other direction. We're going to be given a parabola, and we want to write the equation. So first step again, we want to identify if it's opening left, right, up, or down, and write down the proper equation. So this is opening left to right. The equation would be x equals so we're going to use our vertex and our focus to find the value of p. So our vertex, we can see, minus 3, minus 7. And our focus, minus 2, minus 7. Then to get from our vertex to our focus, we need to do minus 3 plus p. But we know what our focus is. So we know that minus 3 plus p must equal negative 2. Now that we know the vertex and the distance p, we just plug in and write our equation. Four times p, or 4 times 1, is 4. Y minus k, remember, h, k. So y minus a minus 7, or y plus 7. Then plus h, plus a negative 3, is minus 3. For our next parabola, this one's opening up, so the proper equation to use would be y equals. So we have our vertex, so 3 minus 2, and our focus is at 3, 1. So since this one is opening up, we're to go from our vertex to the focus, going up, we'd add a y value. So we'd say 3, and then to go to our focus, we do minus 2 plus some p. But again, we know where our focus is, so our minus 2 plus p we know needs to equal 1. So now we can write the equation. So y is equal to 1 over 4 times p, so p is 3, 4 times 3 is 12, x minus h plus k plus negative 2 minus 2. All right, one more. So this one's opening down, so we're going to use same equation. So vertex is minus 3, 1. Focus is minus 3, 0. Then to go from our vertex to our focus, we take our vertex, and we need to add some p to the y value. But again, we know where our focus is, so we know that that 1 plus p must make the y value here, must be 0. So now we know our vertex and the distance p. We can write our equation. 4p, 4 times negative 1 is minus 4. X minus h, so h is minus 3, so minus minus 3 is plus 3. And then plus k, k is 1, so plus 1.